So I've got sine x, cosine x minus 1/2, cosine x equals 0. So first of all, let me show you what not to do, okay? Because this is probably the first thing some of you want to do, so don't write this down. A lot of you probably are thinking, oh, I'm going to move this over to the other side. And then since there's a cosine on both sides, I'm just going to divide it off, and it's going to go away, and I'm going to have sine x equals 1/2, so x equals pi over 6. If you do this, you will miss an answer. You will not get one of the right answers. The reason comes from this part where you end up just canceling a cosine that goes away. It causes you to lose one of the answers. So, in general, you don't want to find yourself like dividing both sides by something that causes a trig equation to go away. If it causes numbers to cancel out, that's okay. Like if you're doing 3 divided by 3 and you get 1, that's okay. But if you're crossing out a trig equation, you probably are going to lose an answer on that. So, anybody know of something else we could do? We cannot set them both equal to 0. Because are they multiplied together? We could factor out a cosine. Because if we factor out a cosine, they both have cosines here. We could say cosine x times sine x minus 1/2 equals 0. So if we factor it, now these two things are multiplied together, they're equal to 0. Now we can set them both equal to 0. And so sine x will equal 1/2. Okay, so make this where I can see my unit circle again. Right there. Okay, so cosine equals 0 where? Pi over 2. And where does sine equal 1/2? Pi over 6, which is one of the answers that I got whenever I tried this problem, but the other way, but I didn't get the pi over 2. Alright, so let's look at what we got for example 2. We got cosine squared x minus cosine x plus 1 equals sine squared x. So things are starting to get a little more complicated looking here. And so I feel like it's going to be an issue that I've got a sine squared and a cosine squared. So perhaps I may need to change one of these to sine or cosine, like get them to match. Should I change this cosine to 1 minus sine squared, or this sine squared to 1 minus cosine squared? Sine squared should change to 1 minus cosine squared. The reason is I got this cosine right here that's not squared. So I can't do anything with it. It has to stay cosine. So if I do this, I'll have all cosines, which will help me out. So I'm going to have cosine squared x minus cosine x plus 1 equals 1 minus cosine squared x. And then in general, you probably are going to need to move everything to one side. It's just a good strategy for what you're doing here, especially when you have something squared. So I'm going to add this cosine squared x, which will give me 2 cosine squared x. I'm going to subtract this 1. which is actually going to cause it to cancel on both sides. Alright, so what should we do now? Factor out a cosine is the best thing. Because if we add the cosine, then we're going to lose an answer. We cannot divide by 2 right here unless, so like if we divide by 2, we'd have to divide this by 2 and this by 2 and this by 2. So you'd end up like with a 1/2 here, so it won't, you could do it, but it's not going to get you anywhere. And more than likely, you're probably going to forget to multiply that, divide that middle thing. So factoring out a cosine is the best thing to do. And so that gives us 2 cosine x minus 1. When we factor it out, what next? Set them both equal to 0. So we'll have cosine x equals 0 and 2 cosine x minus 1 equals 0. So this turns out to be 2 cosine x equals 1 and cosine x equals 1/2. Alright, so cosine x equals 0 at pi over 2. Oh, wait. Hold on. Let's back up a second. Did this one ask for principal values? This says 0 to 2 pi, which is the whole entire unit circle, right? So we are going to look at the whole unit circle here. It's going to give us more answers than just if we were looking at principal values in most cases. So we will still use pi over 2. That will be an answer. What else? Also 3 pi over 2. 3 pi over 2 is not a principal value, but it didn't ask for principal values. It asked for things 0 to 2 pi. I actually like 0 to 2 pi better because you don't have to use any negative angles. You just use the numbers on the unit circle. So like, for example, like if we had 5 pi over 3, we wouldn't do negative 5 pi over 3. We'd just call it 5 pi over 3. And so cosine equals 1/2 at pi over 3 and 5 pi over 3. So we end up with 4 answers here. Let me just show you real quick what these questions will look like on the test. So you'll get an idea of how we'll do this. Okay, so for example, we got like this example here, sine squared x minus sine x minus 2 equals 0. So this is not the same problem that we did, but you'll notice, actually that's principal values. Well, if it's principal values, notice I've got basically every principal value there could possibly be is listed here, right, for sine. So if you had those answers, you might have 2 answers, you click 2 of them. Some of them will only have 1 answer, some of them will have several. So like, then some of them may be, for these are degrees. So it's 0 to 360 degrees. You would type in the answer here. I will only do type ins if they are if I've asked for degrees. The radians, I'll do check boxes on it. Like here's a checkbox one. That one's asking for principal values. I think I did most of the checkbox ones principal values, just so that you didn't have to click so many answers on that. But that's what that'll look like, and you'll be able to click more than one. You could click every single one if you wanted to, you know. But that's probably a little bit wrong if you do it. should be okay, this one is really easy to mess up. Sine squared x equals sine x for 0 to 2 pi. So what I really want to do there is I really just want to like divide a sign, and it'll get rid of one of them, and then you'll just get your answer. But you can't do that. So in general, if you see one that's sine squared, and you can't just take the square root of it, right? So some of them we had like sine squared equals 1, and we just took the square root of both sides. But I can't just take the square root right here. What do you guys think that I should try? Matthew? Perfect. So you'll see this is a strategy that we're going to use pretty often. Move everything to one side, factor. And so now we can do sine x equals 0. And over here, this is going to give us sine x equals 1. So we're looking at the whole entire unit circle, and we want to know anywhere sine equals 0, what values are those? 0 and pi. Where does sine equal 1? Pi over 2. Is there anywhere else for that one? It is not 3 pi over 2, because what does it equal at 3 pi over 2? Negative 1. So it's just the 1 here. So we'll just have 3 answers for this one. And so even though sine principal values are not like pi here, and that we would usually use negatives, we don't for this because it asks for 0 to 2 pi. All right, what ideas have you got for this one? What? I can't really factor out a cosine here because I don't have like 2 different terms, something separated by a plus or minus sign. And even if I move the 1 over, I'd have cosine x tangent x plus 1 equals 0, so there's not like a cosine in both terms for me to pull out. So here is where we can change our tangent to sine over cosine. So we suggested that earlier, and I told you, nope, let's not do that. It is a strategy you sometimes want to use. It just didn't work very well on that problem that it was suggested on. So now I told you not to cancel sines and cosines. But in this case you need to, because there's no other way you can do it. And it's not like you're dividing both sides to cancel. You're changing the expression and they cancel on one side of the equation. So it is okay to do this as long as you're not like dividing both sides by something that causes them to cancel. So now you can cancel that cosine, and we just get sine x equals negative 1. And we just, I just asked that question, sine x equals negative 1 at 3 pi over 2.
So you're saying if we're changing the tangent to sine over cosine, then we can cancel and we can do it then?
Yes. 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 So if you're changing something to like sine over cosine or 1 over sine or something like that, then it is okay to cancel. But don't do it whenever you're like dividing both sides by something. I know that's a little confusing, and seems like I told you not to do something and then told you it was okay again, but it's a little bit different. All right, what do you guys think here? Here, we will do everything to one side. So we'll do 4 sine squared x plus 4 sine x plus 1 equals 0. Now, we haven't seen one quite like this before, because everything else we just had like a greatest common factor that we could factor out. But think about if I had 4x squared plus 4x plus 1. I could factor it in 2 sets of parentheses, right? So I would have a 2 sine x and a 2 sine x. And I have to have a plus 1 and a plus 1. Which actually these end up being the same, so we don't really have to write this twice. But that we're factoring just like we would if those sines were x's instead. And so we can just say 2 sine x plus 1 equals 0. So sine 2 sine x equals negative 1. So sine x equals negative 1/2. Where does sine equal negative 1/2? Negative pi over 6. I like that Matthew said negative pi over 6 because this one asks for principal values, right? So instead of saying 11 pi over 6, we're going to say negative pi over 6. Okay, I think we can get the rest of these done, probably. All right, so sine to the 4th x equals minus 1 equals 0. So this time we can move the 1 over. Sine to the 4th power of x equals 1. And then how do I get rid of something to the 4th power? I take a 4th root. Thankfully, this is just 1. What's the 4th root of 1? 1. Since this is an even root, though, so if it's square root, 4th root, 6th root, 8th root, you still need to put the plus or minus here. If it is not even, then you would just keep the sign of whatever you have. So like the cube root, you can have a negative cube, like a negative cube root. Cube root of negative 8 would be negative 2. So you can, if you have a cube root, if you see something like that, you keep whatever sign you would have. But if it's an even root, you'll put a plus or minus. All right. And so we're looking for 2 answers here. Where does sine equal 1? Pi over 2. And then negative 1 at 3 pi over 2, which will give us 3 pi over 2 because this asks us to look at the whole unit circle. Okay, 7, we got secants, which just make me feel a little disgusted when I see, because I don't want to deal with them, right? But we have to. So it's already set equal to 0. What could we do here? Factor 1 out. So we'd have secant x times secant x plus 2 equals 0. So that means secant x would equal 0, and secant x plus 2 would equal 0, so secant x would equal negative 2. Now, I don't know anything on the unit circle about secants, right? So let's think about this. This is 0 over 1, right? Here, 0 over 1. So if I change this to cosine, right, then I would have to flip what I have here, which is undefined. Where is cosine undefined? That'd be your x-coordinate. Is there anywhere we've got undefined for our x-coordinate? No. So cosine's never undefined. So you actually don't get an answer from that part. Secant can never equal 0. But over here, if secant is negative 2 over 1, cosine would be negative 1/2. And cosine does equal negative 1/2. Where does that happen? 2 pi over 3. Where else? Because this one tells us to look at the whole unit circle. 4 pi over 3. So we'll get 2 answers here. All right, and so our last one here, for our examples, I've got sine squared, but over here I've got cosine. So what should I do with that sine squared? Let's do a 1 minus cosine squared equals 1 minus 2 cosine x. And then let's move everything to one side. I'm going to move everything to the right-hand side because it's better if your cosine squared is positive. So I'm going to add that cosine squared x, so it'll be positive cosine squared x. We'll subtract that 1, which means it's just going to cancel on both sides. So I get 0 equals cosine squared x minus 2 cosine x. And now we're back to something that we can do. Factor out a cosine. So we get cosine x equals 0 and cosine x equals 2. Where does cosine equal 2? What? Nowhere. So here's another one of those cases where we just don't get an answer from that part. But cosine does equal 0 at pi over 2. And this is principal value, so that'll be our only answer here. So, I want you guys it'd be better to have homework tonight than over the weekend, don't you think? Let's do this for homework. That'll leave just the third part of these notes to do tomorrow, which hopefully we can get done in class. Okay, so do these for homework. The rest of them, so like right here, it starts to say that this is homework. So do the rest of them. There.